And we're back, and with me right now is John Valliant, who is the range manager here at Wallops Flight Facility. And John, what does that mean?
Well, I'm the range project manager. I'm one of probably about 6 or 8 people who run various projects here at the range. We run aircraft projects, rocket projects. We do a lot of UAVs, which are unmanned,
uncrewed,
uncrewed aircraft. Basically, we have a test range. We do a lot of work with military, with the Navy and Air Force and whatnot, doing tests of sounding rocket pieces and various data telemetry transmitters and whatnot. So basically, we sort of work to just basically coordinate these so that it gets launched.
Okay,
Right.
so once it's launched, does your job start or stop?
It continues.
Okay,
Right.
so
Yeah.
you're part of this whole mission from beginning to end, then,
Yes.
pretty much. We've heard a little bit about how high, the altitude that it's going to go,
Okay.
and that we know it'll land in the Atlantic Ocean there,
Right.
but about where?
It'll land somewhere probably between 100 and 150 miles to the east of Cape Hatteras.
Okay,
Yes.
so quite a ways from here.
Yes, it is.
Yeah.
Yes.
So how do you track that?
We track that with the radar systems. The vehicle has a beacon, basically a transmitter that pulses very quickly. What the radars do is they track this beacon as it goes through flight. We also track the motors. There are 3 motors on this. If you have looked at the screen here with the vehicle on the launch rail, there are 3 motors. The first 2 drop out fairly quickly offshore. The second motor, or the third motor, excuse me, is a Black Brant, and it takes the vehicle into space. So then the Black Brant falls off, and it lands off of North Carolina as well. They both land pretty close to each other. The IRVE itself comes down, and of course it is a re-entry vehicle, so it basically is meant to slow down. When it splashes, which will be about 25 to 30 minutes after it's launched, we have a really nifty vessel from the U.S. Navy. It's called the Stiletto, and if anybody wants to look up the U.S. Navy Stiletto on Google, it looks like something from a Batman movie.
Oh, right.
Honestly, it's a tri-hull littoral or coastal vessel, and it's going to be going out with a crew of about 8 or 10 people. They're going to deploy a small boat out of a ramp in the back. It's really neat to look at on Google,
All
honestly.
right.
And they're going to go attempt to recover this. It's going to be a really tenuous task to pull this up, but that's what we're planning on trying to do.
So how many pieces will actually land in the water then?
Well,
hopefully if IRVE comes in a single piece, right?
Well, we have the 3 motors that are coming in. We have a payload nose cone that's going to deploy, and then we have the IRVE itself.
Okay.
So anyway, we have the 3 motors, a nose cone that comes off, and that comes off in space. Honestly, the nose cone comes off via air spring, and then the inflation begins for this thing. So all of we calculate where each of these pieces are going to fall.
Okay.
Yeah, because we have to notify mariners, and
Right.
we actually have aircraft that are out doing surveillance to make sure that the motors are and everything's in place where it's supposed to.
Okay, all right. So tell me a little bit about the process that goes into deciding where this is going to be, where you're going to shoot. We noticed a few minutes ago that they had elevated the rocket just a little bit as they were doing a communication test with it. Obviously, then they laid it back down. That's not how it's going to shoot off.
No.
So tell us about all of that whole process and what happens there.
Well, the dynamics that are involved in this, basically what the project is, I'm sure the gentlemen who were speaking before, the scientists, they're looking at how the angle that this will come back in through the atmosphere, which is basically the driver of how we point this. These are unguided rockets. It does have a spin on it, so basically the spin, it's basically like firing an arrow. The arrow is spinning so that it stabilizes where it goes, as opposed to if it weren't, it would be veering off various directions. So they give us their requirements, basically how they want it to come in. The reason we're firing it off in North Carolina is because we have a telemetry and radar site in North Carolina that we're using, that we track it tangentially as opposed to from behind. So anyway, that's a good reason to be firing it that way.
Right.
It gives us another data point.
Okay.
Yep.
So what will you do after the launch is completely over? Breathe deeply, relax.
a sigh of relief. Yeah, this has been going on for about 2.5 years now.
Yeah, it doesn't.
It's a long time.
It is
coming.
a long time, a long process,
really
and it doesn't.
Yes.
It doesn't just happen overnight.
No,
we've
it's
seen
very
that it takes
complicated.
a huge team to work
Right.
with it.
Mhm.
So, are you involved in any other launches?
I have 4 launches coming up through the end of September this year.
You're to be very busy.
I have a lot of. Yeah, we're very busy.
Yeah.
This is a extraordinarily complex
Right.
launch, though. We do a lot of student launches. I have a student launch coming up where we have university students that put payloads on there, which is really fun.
Right.
It really is. I love working with the kids. I've got a launch coming up where we're testing. We do motor tests where we basically use new stacks.
Mm-hmm.
They looked at what the stack that we have, which stack means the various how the motors are put together.
Right.
We're testing a new stack in late August, and then in September we have the Department of Defense coming in here, and they're running some tests. So it's busy. We have a very busy
So
range.
you do everything from very small rockets to pretty
Yes.
good size ones then.
Yeah, we have student
Launch
elementary and middle school students that come in here, and they fire model rockets and basically start out their mathematics as mathematicians, as elementary and middle school students, learning how to do simple trajectories.
That's pretty
It's fun.
exciting. That
It
is
is.
fun.
It
So what's been your favorite to launch your mission out of here?
Well, this one certainly is complicated. The premise of planetary reentry is fascinating. I mean, it really is.
It is.
This has been done twice before at various scales. So we're this is actually, if you want to look at it in very simple aspects, it's higher and steeper. Basically, we have a larger motor. We go up and down. But I personally enjoy the university students. I really do. I think it's just more fun.
So what advice would you tell those kids that are watching, those university students that are saying, how could I get something like that done?
I would say if you guys want to get into a business like this, I think the main point is do really extremely well in your science and math, and of course English. Being bilingual, anything but science and math are really the strong points.
Right.
Honestly,
So
it's quite
John,
obvious.
what was your career path that brought you here?
I started out. My background educationally is earth science and geophysics. So I started working here actually
An
about
earth
21.
scientist, we love it.
Yeah, so it's really fascinating. I started here actually doing environmental science, and from there I went up to Goddard Space Flight Center and worked out of near DC for 7 or 8 years, and went into the Mission Operation Control Center work where we actually do satellite orbit analysis and the propulsion of it, and came down here and started working in the rocket industry. Flew in research aircraft for a few years, and now I'm back in rockets.
Where will you be physically when this launch is going
I'll
on?
be sitting one table over from where we are now.
Okay, so you'll actually be here in Mission Control.
Correct. Yes.
And being part of the whole thing. Yeah.
It's my count.
Phew. All right. Well, thank you very much for joining us. I know
You're
it's a
quite
busy
welcome.
time, and
It
we
is.
really appreciate it.
It's fun.
So thank you.
You're quite
Coming up
welcome.
in just a few minutes, we'll be here with Nathaniel Miller. So let's take a short break.